Welcome back to another explainer. Look, today we're jumping straight into a really exciting builder's journey. We are going to roll up our sleeves and build a complete SCADA system from absolute scratch. From that initial software download, right up to the point where you've got a beautiful, fully functioning HMI dashboard, we are covering the whole shebang. If you've ever felt intimidated by all the moving parts of industrial automation software, well, you're in the right place. We're going to break it all down step by step.
Do you want to build a complete SCADA project from installation to a functioning HMI dashboard all by yourself? I know, industrial IT can seem like this tangled web of networks, databases, and PLCs. But here's the truth. It's entirely built on logical, totally manageable blocks. Today, my goal is to validate that yes, you absolutely can overcome this complexity. By the end of this explainer, you're going to have the exact blueprint to do it.
Okay, let's dive into our builder's arc. First up, installation and communication setup. Then, historian data tracking. Next, SQL Database Integration. After that, Python data automation. And finally, visualizing it all on an HMI dashboard. Let's get to it.
Phase 1. Installation and communication setup. Because, every great build starts with a rock-solid foundation. First things first, let's actually get the software running. You'll head over to inductiveautomation.com and download the Windows software. It's just a straightforward 800 megabyte executable. Once you've got that installed, simply open your web browser and type in localhost:8088. That right there is the default port where your Ignition gateway lives. And hey, if you're worried about licensing right now, seriously, don't be. You can practice using their super generous 2-hour trial, which by the way, you can reset infinitely, or just download their completely free Maker Edition. So, zero excuses not to start building right now.
Now, to make our software actually useful, it needs to talk to the physical world, right? Enter the OPC UA Server. This is an incredible built-in tool within Ignition that acts as your universal translator. It completely handles the communication with your external physical devices, whether that's an industry-standard Siemens S7-1200 PLC or even a smaller, maker-friendly Arduino Opta PLC. It just seamlessly bridges that gap between your digital software and your physical hardware.
And this brilliantly illustrates the absolute golden rule of network communication. If your computer's Ethernet IP is 192.168.1.106 and your PLC device IP is 192.168.1.100, they absolutely must be on the exact same network subnet to talk to each other. If your computer's on one network and your PLC is on a completely different network architecture, there's no way the OPC UA server can do its magic. So always double-check those IPs.
Moving right along to Phase 2, historian data tracking. We've got our foundation laid, so let's start moving some data.
So what exactly is a historian? Well, it's the absolute standard tool in automation for continuously tracking and recording the value of a tag over time. Think about a temperature sensor reading, or maybe a pressure valve gauge. You don't just want to know what it is right at this exact second. You need to know what it was 10 minutes ago, or yesterday at 3 p.m., right? The historian logs this continuous stream of data for you, effortlessly.
Now, what's really interesting about this slide is the clear distinction in data storage methods. Over on the left, SQLite is Ignition's default internal file storage, and it is absolutely perfect for the continuous firehose-style tracking of the historian. But looking on the right, SQL is a full external database used for event-based tracking, saving data to specific, highly structured tables. We're going to get to that SQL part shortly, but for our historian tracking right now, we are going to rely on that default SQLite database.
Setting this up is just unbelievably simple. You just open the tag editor for whatever tag you want to track, scroll down, set the history property to true, and then select that default SQLite database as your storage provider. Boom! That's literally it. You are now historically logging industrial data.
But look, data is kind of useless if we can't actually see it, right? To visualize this continuous history, we just pop into our HMI designer. You simply grab the power chart from the Perspective Components palette and literally drag and drop it right onto your screen. It automatically browses your tags and instantly creates a live graphical trend of your PLC sequences or timers. It is so incredibly satisfying to watch your data just come to life with a single drag and drop.
All right, on to Phase 3, SQL Database Integration. We've mastered continuous data, now we need to handle specific events.
So why do we need a totally different approach here? Well, because sometimes you don't need a continuous graph. You need a highly specific log. You need to know exactly when a machine started, exactly when it stopped, and critically, which user was logged in and operating it at that exact moment for quality control. This requires structured relational tables, and that means we need full SQL database integration.
To do this, we open Ignition's database query browser. Using a really simple create table command, we're making a dedicated place for our event data. We create columns for our run count as an integer, our username as text, and our start time as a datetime object. This structure is basically the rigid filing cabinet where our specific event records will live. Take a second to just absorb that syntax.
Once that SQL table is created in the database, we need a way for our SCADA software to hold that information before sending it over. So we create memory tags in the Ignition Designer for run count, username, and start time. These basically act as temporary holding cells for the specific event data, perfectly mirroring those columns we just built in our SQL table.
Phase 4, Python data automation. This is where it gets really fun. We're going to use accessible scripting to automate the flow between our tags and our database.
The logic here is absolutely vital. We use gateway tag change events. See, we don't want a script just constantly flooding our database. We only want to save data when an actual event triggers it. For example, when a PLC sequence step changes from step 1 to step 2, that specific tag change is what triggers our Python script to wake up and do its job.
Inside that script, the very first thing we have to do is grab the data. We use the system.tag.readBlocking command to reach out to those memory tags, the username, the run count, and pull their current values right into our Python script, holding them in variables ready to be processed.
Before we push that data to the database, I want to share a really vital troubleshooting tip. Format your dates explicitly. If you've ever worked with databases, you know they can be incredibly picky about how dates look. By using the system.date.format command and forcing it into a standard year, month, day, hours, minutes, seconds format, you are going to prevent a massive amount of SQL database errors. It's such a small step, but it literally saves hours of debugging down the road.
So the crucial point is this. Here is the big payoff. Once we've read our tags and formatted our dates, we execute system.db.runPrepUpdate. This incredibly powerful command pushes all that gathered data directly into our SQL database using an insert into query. Just like that, your PLC event has been perfectly captured, formatted, and permanently recorded in a structured database table.
Finally, Phase 5, HMI visualization. We've done all the back-end heavy lifting, now let's bring it all to the surface in a beautiful, user-friendly dashboard. Visualizing this data is deeply satisfying. First, you create a special kind of tag called a dataset query tag and write a really simple select all query to grab the data we just saved. Tell it to update every 5 seconds so it stays super fresh, and then simply drag this tag onto your HMI screen, dropping it as a table component.
You'll immediately see your data populate, but I want to leave you with one final polished bonus tip. If the dates look like some strange string of numbers in your new table, don't panic. Just go into the table's column settings and explicitly set the date format to datetime. It cleans everything up instantly, making sure your HMI dashboard looks crisp, professional, and completely ready for an operator to use.
And there you have it. You've downloaded the software, connected to a physical device, tracked continuous historical data, integrated a full SQL database using Python, and visualized it all on a gorgeous, clean HMI dashboard. You just built a complete SCADA system from scratch. So, I have to ask, now that you hold these foundational building blocks, what complex industrial process will you automate and visualize next? The possibilities are literally endless. Keep building, and I'll catch you in the next one.